Now I haven't made the table for the y equals x squared function, and I, just because of space considerations, I didn't include the -1/2 and the 1/2, but those are part of what we do when we make the table for our basic values, okay? But we know that the values for these x coordinates, and we need to be really familiar with these, and I believe we are what, 4, 1, 0, 1, 4. Those would be our y values. 4, 1, 0, 1, 4. I've actually got those values over here. Those are the values we get if this was just x squared instead of 2x squared. Of course, now if we want to get 2x squared, we take those values, 4, 1, 0, 1, 4, and multiply each of them by 2, and we get the value of 2x squared. So these are the values of our 2x squared function. Okay, then we want to get our 2 times quantity x minus 4 squared. We could use -2 through 2, but we'd just get a bunch of big numbers, and we wouldn't necessarily know what most of them mean or how that even relates to the graph of a parabola. It wouldn't be obvious that we had a parabola. What we need to do is recognize that replacing x by x minus 4 changes the values that we would be squaring. And what we want is we want to use x values that give us the same y values that we get up here. Okay? Well, we're replacing x by x minus 4, meaning that x values, in order to give us the same y value, the x values have to be 4 units bigger, so that when we subtract 4, we get the same x values that we used up here, or that we're squaring the same values that we would up here. So if we increase all our x values by 4, then the values from -2 through 2 become 2 through 6, because increase -2 by 4, we get 2. If we increase 2 by 4, we get 6, and similarly for the rest of the numbers. Okay, so without even calculating it, although we should calculate it to be sure we understand this, we know that increasing all our x values by 4 is going to give us the same y values we got up here. If we increase every one of these x values by 4, we have to get the same y values. So I just wrote the y values down. Now you can plug all of these numbers in and verify that that really happens, but if I've increased all the x values by 4, I have to get all the same y values. And that's why the graph shifts 4 units to the right. The x values have to be 4 bigger in order to give us the same y values. So this is why, from the green graph to the purple graph, from the 2x squared to the 2 quantity x minus 4 squared, we shift 4 units. Every point of the graph shifts 4 units to the right. It's a little hard to understand, and it's fine if all you know is the rule, but some people want to understand it a little more deeply. They remember the rule better if they know why it works. Okay, now the rule is just, if you replace x by x minus 4, everything shifts 4 units to the right. So the 2x squared graph will shift 4 units to the right to give you the 2 quantity x minus 4 squared graph, and that's what we've depicted already. You don't have to understand this. It's a little hard to understand, but it's accessible. But if you want to, there it is. And then, of course, the y equals 2 quantity x minus 4 squared graph shifted vertically -3 units gives us, well, all our y values will be 3 less. Downward vertical shift. Okay, so we get y equals 2 quantity x minus 4 squared minus 3, and that's the shift we see here, and there's the graph. I didn't do the table, but you could do the table and see why that works.